Okay. So we were doing this integration, and I hope the things are clear to you. So I think the V leading term, I hope, I think for n equals to 1, I think this should give a non-zero contribution. Let us see. So I'm writing cos theta upon 4 pi epsilon naught, and there would be r squared term also. This minus a to a, so k would come out. So take k common out. Minus a to plus a z sine pi z upon 2a dz. So let us write this as I1 and let us calculate it separately. So how to solve this I1? I1 would be by parts I would integrate. So z into 2a upon pi cos of pi z upon 2a from minus a to plus a. This would go to 0, I hope. And then minus integration of z, derivative of z is 1. And then integration of this ones would give you minus minus plus. So this will be 2a upon pi. And this is from minus a to plus a. And then this will be cos pi z upon 2a dz. And then I think this first integration would go to 0. So I'm not worried about it. My I1 would correspond to writing 4a square upon pi square. And then I think this will become 2. I think, is that clear? If I'm not wrong, I guess. I hope I'm not wrong. So there's a mistake over that.
4a by pi आ रहा है।
हाँ बेटा,
मेरा तो 4a by pi आ रहा है।
4a by pi तो नहीं आ सकता यार।
मतलब a स्क्वायर कैसे आएगा?
देखो
अच्छा ठीक है, हाँ उससे पाई बाय
एक
2
बार
इज
इंटीग्रल
रिक्वायर्ड।
करोगे तो साइन पाई जेड अपॉन एक बार इंटीग्रेशन करोगे तो कितना आएगा? कॉस पाई जेड अपॉन 2a। पर एक और बार इंटीग्रल करोगे तो कितना आएगा? साइन,
यस सर, यस सर, यस
है ना? तो
सर,
फोर
साइन
ए
ए
स्क्वायर अपॉन
स्क्वायर।
पाई स्क्वायर तो आएगा ही। और ये तो आएगा साइन पाई जेड अपॉन 2a को फिर माइनस ए से इंटीग्रेट मतलब लिखेंगे तो आई थिंक 2 4a स्क्वायर अपॉन पाई स्क्वायर तो आना ही चाहिए, आई गेस। बाकी तो इज दैट क्लियर और नॉट क्लियर?
यस सर।
Or is there a mistake somewhere? I don't. I think integration sin z into sine pi z upon 2a. This is fairly easy to see. This would be equivalent to writing. तो इसको ढंग से करने का इधर एक बार ढंग से कर 2 मिनट लगेंगे। गलती क्यों ही कर रहे हैं तुमको? So इसको यहाँ पे एक बार ढंग से करना। So z sin pi z upon a upon 2a dz ये तो करना। तो देखो कैसे करेंगे, z को एज इट इज रहने दो। इसका इंटीग्रेशन कितना होगा? cos pi z upon 2a और एक आएगा 2a upon pi। इज दैट क्लियर? फ्रॉम माइनस ए टू प्लस, इज दैट क्लियर? तो देखो a पे a रखोगे तो cos pi by 2 is 0, माइनस रखोगे तो it will be 0 minus the derivative of z is 1 and then integration of cos pi z upon 2a. So integration of cos pi z upon 2a is 2a upon pi and this would be sine pi z upon 2a dz. Is that clear? And again integration over this would give you 4a square divided by pi square cos of, एक मिनट कुछ गलती कर रहे क्या? cos of pi z by 2a. ये भी जरूर जाएगा क्या? I don't think so. Sin pi z upon 2a would give you cos. अच्छा cos था ना? So this will give you I
कॉस
think cos pi z upon 2a एक negative positive हो जाएगा and then again cos का होता है sin. Sorry. So from minus a to plus a. So I think this is clear. So ये हो जाएगा 2 times ये हो जाएगा 8a square upon pi square. Is that clear? ये तो clear है, ठीक है? So your leading term would then correspond to your v leading term would correspond to V dipole term because monopole term is now 0. So you have this dipole term. This is K cos theta divided by 4 pi epsilon naught r square into I1. And I1 is, I think, 8 a square upon pi square. So your this would be the term, right? Isn't it?
यस
So
सर।
your dependence is over r, 1 upon r square. So clearly, your dipole term would be the leading term. Is that clear or not clear? देखो गलती कर रहा हूँ करने में।
क्लियर।
चेक कर लो एक बार, कोई गलती तो नहीं है, बाकी सब ठीक है। तो नहीं, ये चीज सही है कि गलत है, जल्दीबाजी में तो नहीं कर रहा हूँ चीज। चेक कर लो, चेक कर लो, चेक कर लो। इज दैट क्लियर, नॉट क्लियर? कुछ गलती कर रहे हैं क्या हम लोग करने में? चेक कर लो, इज दैट क्लियर और नॉट क्लियर? कहाँ गया? देख लो ना इसको एक बार। है ना, सही है ना ये?
क्लियर तो कुछ है ही नहीं।
हाँ जी, सॉरी।
हाँ भैया क्लियर, ये तो
क्लियर।
सामने ही
चलो
है।
एक और एग्जांपल
हाँ
लो। लेट अस टेक अनदर एग्जांपल वेयर लैम्डा इज गिवन बाय साइन ऑफ pi z upon a, and the charge density is distributed like from minus a to plus a along the z axis. Along the z axis, pi z upon a. So in this, uh, इसको constant और multiply करो, let's say k. Okay, so now here also you can see from minus a to plus a, if I integrate lambda dz, I think I will get 0. नहीं नहीं, integration देखते हैं. I will get what? K minus a to plus a, and sine pi z upon 2a, I'll get a upon pi, and then I will get cos pi z upon a. Is that clear? Is that clear, beta? And negative sign also. So I'll get minus k, and at a, cos pi is minus 1, and at minus a, cos minus pi is also minus 1. So overall, your V monopole term would be 0 because total charge is 0. So it may be possible, that the dipole term would become the leading term. Is that clear?
Yes, sir.
Okay. And there is just an integration to do. So what will be the dipole term? So dipole term would be 1 upon 4 pi epsilon naught r square cos theta integration. I think it would be z k sine pi z upon a dz. Is that clear? Now try to integrate this thing. So what would be integration like? 1 upon 4 pi epsilon naught r square cos theta, and k will also come out. So this integration would again be equal to what? K, sorry, z cos pi z अपॉन ए. बस इसमें यहाँ दिक्कत आ गया कि cos pi z अपॉन a है और a अपॉन pi आएगा आगे, and this would be from minus a to plus a. Just reverse the minus integration from minus a to plus a. Derivative of z is 1. Integration of this is plus a upon pi cos of pi z upon a dz. Okay, is that clear? And in another, I'll take another step. This is k upon 4 pi epsilon naught r square cos theta. If you take minus a, this would be cos pi. Cos pi is minus 1. And again, minus of, समझ लो ये 0. देखो एक बार a रखोगे तो कितना आएगा? माइनस ऑफ a स्क्वायर पाई cos pi, because cos of minus pi रखो चाहे प्लस पाई रखो एक ही बात होती है. नेगेटिव ऑफ a square upon pi cos of, you get first bracket done, and this integration would be equivalent to writing a upon a square upon pi square sin of pi z upon a. कुछ तो गलती करना करने में है ना, जो भी है. आई थिंक फ्रॉम माइनस a to plus a. आई होप इट इज क्लियर. यहाँ तक समझ में आया कि नहीं? कुछ तो गलती नहीं हो रही ना? चेक कर लो एक बार. देखो k अपॉन 4 पाई एप्सिलॉन r स्क्वायर cos थीटा यहाँ तक तो ठीक है. फिर इंटीग्रेशन z की पावर 1, बिकॉज r की पावर n होता है ना, तो n equal to 1, n equal to 1 के उसमें ठीक है, डन। इज दैट क्लियर नॉट क्लियर? देखो यही तो था, सेम टू सेम तो चल रहा है, बस यहाँ पर मैंने पाई जेड अपॉन 2a की जगह पाई जेड अपॉन a कर दिया। सो पाई जेड अपॉन 2a की जगह पाई जेड अपॉन a कर दिया। इज दैट क्लियर नॉट क्लियर? हाँ ना तो बोलो बेटा।
Yes, sir. Yes.
ओके,
हाँ भैया।
सो इफ आई रिप्लेस माइनस ए हियर, सो यहाँ पे क्या आएगा? ये समझ पा रहे हो? कॉस पाई जेड अपॉन 2a का इंटीग्रल क्या होता है? कॉस पाई जेड अपॉन 2a, और कॉस पाई जेड अपॉन ए, और एक डिवाइडेड बाय पाई अपॉन ए अपॉन पाई आएगा, और एक नेगेटिव और आएगा। नेगेटिव आएगा तो मैंने क्या किया, आई हैव इंटरचेंज द लिमिट, एंड देन माइनस ए अपॉन पाई 1 sin pi z अपॉन ए का इंटीग्रेशन कितना आएगा? माइनस ए अपॉन पाई cos pi z अपॉन ए। अगेन दिस cos pi z अपॉन ए इंटीग्रेशन फ्रॉम माइनस ए टू ए रखा तो कितना आएगा? 0। माइनस ए रखेंगे तो क्या आएगा? 0, बिकॉज cos sin pi is 0 and sin minus pi is also 0. So I think this term will not contribute. Forget about this. Now think about this term. Think about this term. So what this term would give you? This term would give you, I think, a non-zero contribution. This is k upon 4 pi epsilon naught r square, and there is a cos theta as well. But again, this is 2 times a square upon pi. Why 2 times? Because cos pi is minus 1, so this will become a square upon pi. Cos pi is minus 1, so this will become a square by pi. So you will add it up. Here also you'll find that your v dipole is non-zero term, or v dipole is the leading term in the potential. Is that clear or not clear? समझ पा रहे हो मैं क्या बोल रहा हूँ देर से? ठीक है, सो ये थोड़ा सा हल्का फुल्का तुमको, आई थिंक इज गुड इनफ कि हमने कुछ क्वेश्चंस ले लिए, और भी क्वेश्चंस लेते हैं, बट लेट अस गो अहेड इन द टॉपिक। ओके, ये चीज समझ में आ गई?
हाँ भैया।
Oh, good enough. चलो पढ़ो आगे। So let us take a few questions, so that let us take a new topic as such. The topic is called as origin of coordinates in multipole expansion. So I'll take a new topic that is called as origin of coordinates. कल से वैसे सुबह ही लेंगे क्लास ना, परेशान मत हो, आज की बात है। मल्टीपोल expansions. Okay, so origin of coordinates in multiple expansion. This is what we were doing yesterday, and we got somehow badly stuck with somewhere. So that is why I dropped that idea. Let me try to execute it once more. Let me try to execute it once more. So देखते हैं अगर वो execute हो जाएगा, then it will be good enough. So let us consider an array of charges. So I'll write it from here. So let us consider an array of charges. So let us consider an array of charges, and all placed along the z-axis. So all are placed along the z-axis. All are placed along the z-axis. So I'm just taking the z-axis like horizontal only, so that it doesn't disturb you. और यहाँ पर हम लोगों ने origin पकड़ के चल दिया, ठीक है? Let us take all the charges on the z-axis such that q1 is placed at a1. This is my q1. It is placed at 0, 0, a1. q2 is placed at 0, 0, a2. q3 is placed at 0, 0, a3, and dash 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 dash. qi is placed at 0, 0, a9. Is that clear? Or let us take a point which is far away. This is far away from all these AIs. So let us take yet another point R, which is very, very far away from any of these AIs. Is that clear? Okay, and one can clearly see that if this is theta, so this will take the form r vector minus a1 vector, come on. Similarly, this will be r vector minus a2 vector, come on, and so on and so forth. And this would be, I think, r vector minus ai vector, come on. Is that clear? So this is how it is going to be. Is that clear or not clear? Okay. And what would be the potential like? So potential would be equivalent to writing summation KQI divided by root over r square plus ai का square minus 2ai r cos theta. Is that clear? यहाँ तक किसी को दिक्कत? And what I can do, I can write, I can take this 1/4 pi epsilon r outside, and I can take this even r square outside. I can take this r square also outside. So I'll take this r square outside. So this will come out as r. And now you have summation qi. And again, this would be equivalent to writing summation n equal to 0 to infinity. And this will be pn cos theta into ai divided by r ka whole square. Whole square power n. Is that clear or not clear? So sorry. Is that clear or not clear? आना तो बोलो फटाफट से.
Yes, sir.
Okay, good enough. अब थोड़ा ध्यान से देखना ना, क्योंकि कल हम इधर ही फंसे थे. Okay. So this would be, हाँ जी बोलो. So v as a function of r would be 1/4 pi epsilon naught, and this is r, and this is summation qi here. And if I just try to like 2 या 3 term तक खोल के देखते हैं, so this will be like equivalent to writing 1 plus ai upon r cos theta plus ai upon r का whole square, and I will write 3 cos square theta minus 1 by 2, and then plus all these are plus. Is that clear? And so I'll write v as a function of r, that I'll multiply all these things. So I'll write 1/4 pi epsilon naught r, and this is summation I belongs to natural, not natural, I would say. चलो ठीक है, I equal to 1 2 3 4 ये तो था. I belongs to natural would do is equal to summation qi plus qi ai upon r cos theta, or I will write p1 cos theta here for simplicity. And this would be summation qi, summation चल रहा है ना, भूलना मत उसको, upon r, and this is p2 cos theta. And कुछ terms बढ़ते जाएंगे, I'm not bothered about it. Is that clear or not clear?
Sir, I infinity तक जा रहा है क्या?
I infinity तक जा रहा है, जितने ज्यादा charges ले सकते हैं, and this r is going as large as possible. हम लोग एक linear array of charges लेते हैं, ठीक है? So like चलते जाएंगे, these charges is going on, and this r is way too far away. Like, is that clear or not clear?
Sir, सबका फिर r distance कैसे ले सकते हैं सर?
हाँ बेटा.
सबका डिस्टेंस अलग अलग होगा ना सर, एक फिक्स पॉइंट से.
This r is this r represents your position vector from the origin. ये जो r ना, this is your position vector of the sort point from the origin. ये r तो फिक्स ही है, ये आपके जैसे जैसे ये अलग होते जा रहे हैं वैसे वैसे. And this r is suitably very larger than your ai's.
Yes sir.
Okay, so this r is the position vector of the sort point where you want to find your potential from the origin. So this will remain like sort of constant only, but this r is way too large than this ai's. ऐसा समझो.
Okay sir.
Okay.
Yes sir.
अब थोड़ा हम ध्यान से देखते हैं इसी चीज को. थोड़ा अगर ध्यान से देखोगे तो what it is showing you, this is a sort of discretized version of your multiple expansion. If you see, this is a discretized version of your multiple expansion, isn't it? If you see that this is a discretized version, I will write this is a discretized. Okay, I'll write इधर ही लिख देता हूँ. This is discretized version. Okay, so this is your discretized version of the multiple expansion that we did for the continuous volume charge distribution. And what does it say? It says that there would be a term which contains summation qi, then there would be a term containing qi ai divided by r, and then there would be p1 cos theta. And if you remember this term, थोड़ा सा ध्यान से देखोगे तो एक ऐसा है qi into ri vector. देखो ri की जगह, because now you are on the linear scale, So now Ri would be equals to Ai. So this is corresponding to your 2 की power 1 pole moment or dipole. ठीक है, this is corresponding to 2 की power 0. So this is your monopole moment. So this is corresponding to 2 की power 0 pole moment, or you can say monopole. Actually होता क्या है, whenever we study multipole ना, तो हम लोग कोशिश करते हैं, we try to make arrangement in the powers of 2 की power i's. So इस तरीके से मतलब this is how we write things up. So dipole means 2 की power 1 pole or simply dipole. Is that clear? मतलब ये सब लिखने का तरीका कुछ. And then you will have summation. Summation. This would be qi into ai का square, and then you will have divided by. अच्छा एक r square भी तो होना चाहिए यहाँ पे. This will be r square और एक r बाहर चली गई, ठीक है, उसको मत बोलना, ठीक है. This r square and this will be p2 cos theta, and this would be corresponding to quadrupole moment. Is that clear? This is corresponding to quadrupole moment, so on and so forth. Is that clear or not clear with that? ये चीज समझ में आई है? ओके, गुड इनफ. अब देखो, अगर इसी चीज को मैं लिखना चाहूँ, थोड़ा ध्यान से देखते हैं. दिस इज आर स्क्वायर. अगर ये आर अंदर ले लिया तो दिस इज आर स्क्वायर. दिस इज आर की पावर 3, आई गेस. R की power 3, right? So what I'll do, if I want to write my potential, I will write it as summation n equal to 0 to infinity. This will be mu I. What is mu I? Mu I is your ith multipole moment. If you can say multipole moment, ith multipole moment, or 2 की power I pole moment. For example, 2 की power 0 pole moment is monopole moment, 2 की power 1 pole moment is a dipole moment, so on and so forth. And there is some like इसको n ही लिख दो ना, कोई फर्क नहीं पड़ रहा, because first is, second is mu1, third is mu2, so on and so forth. And here I will write simply Pn cos theta, and here I will write r की power n plus. Is that clear? ये चीज समझ में आई कि नहीं समझ में आई? Is that clear or not clear? ये mu n समझ पा रहे हो? This mu n is, या फिर mu I को मैं लिख दे रहा हूँ summation qi into sorry, है ना? So mu I sorry, I'll write mu n. ओके, थोड़ा ध्यान से देखो, यहाँ ए आई है, यहाँ ए आई स्क्वायर है, या ए आई की पावर 0. इज दैट क्लियर? है ना? फटाफट बोलो बेटा.
हाँ भैया.
है ना? दिस इज mu1, दिस इज mu2, दिस इज mu नॉट, दिस इज mu1, दिस इज mu2. सो उस सेंस में कह रहा हूँ. है ना? फटाफट बोलो, नहीं तो फिर वापस दिक्कत होगी इसमें. फिर कंसंट्रेशन, है ना, इसमें कंसंट्रेशन लैप्स हुआ नहीं और फिर अपन गए नहीं. नाउ लेट अस ट्राई टू चेंज द कोऑर्डिनेट सिस्टम. सो नाउ लेट अस ट्राई टू चेंज द कोऑर्डिनेट सिस्टम टू, let's say, a different now let's say my origin is shifted to r vector p, and now if you see from the displaced origin, this distance, because this is r vector p, so this is r vector p, this is r vector. Now from the displaced origin, this distance would be given by r vector minus rp vector. Is that clear? ये चीज समझ में आई? So the new distance would be given by this r vector minus rp vector. ठीक है, तो थोड़ा सा इसको सिंप्लीफाई कर लेते हैं, इसको डिलीशन नहीं रहता. अब देखो, अब थोड़ा यहाँ ध्यान से देखो. इंस्टेड ऑफ r, now you will have 1 upon r vector minus r vector p. Come on, right? But instead of r की power n, you will have 1 upon r vector minus r vector p की power n. Is that clear? Well, instead of this, you will have this. Yes or no? ऐसा मान लेते हैं, ये कुछ नया थीटा डैश मान लेते हैं. ठीक है, कुछ नया थीटा डैश इधर, और ये हो गया तुम्हारा आर पी वेक्टर, ये हो गया तुम्हारा आर वेक्टर, और ये हो गया तुम्हारा आर वेक्टर माइनस आर पी वेक्टर. इजंट इट? मॉड में ले लेते हैं. ठीक है, So अगर इसको थोड़ा सा expand करोगे तो you will find that you will get the powers of 1 upon r की power n, and then all the higher order terms you will get that there would be some function of theta. I'm not saying there would not be some function of theta dash. I would say like this theta dash. There would be some constant, and then there would be terms which will involve rp. So if you want to see that, here you can see that this r vector minus rp vector, this can be written as mod can be written as 1 upon root over again r square plus rp ka square minus 2 rp into r cos theta. And if you take that r is very, very greater than rp, then certainly you can take a binomial expansion. And then this is one of, this is summation n equal to 0 to infinity. This is pn theta dash and cos theta dash. And then you have this rp upon r की whole power. Is that clear? इस तरीके से इसी एक्सप्रेशन को लिख सकते हैं. So except n equal to 0, for n equal to 0 you will not have any rp term, but for n equal to 1 and further you will find that there would be certain terms. So if 1 upon r की power n is now replaced by 1 upon r vector minus rp vector की power, like r vector minus rp vector का mod की whole power n, then this will correspond to this and like higher order terms. Is that clear or not clear? हाँ या ना बोलो फटाफट. ये चीज समझ में आई कि अगर मैं r की पावर n को, यहाँ n+1 लिखा कोई बात नहीं, अगर मैं r की पावर n को रिप्लेस करता हूँ r वेक्टर माइनस rp वेक्टर के मॉड से, बिकॉज नाउ योर r वेक्टर क्या था? r वेक्टर वाज द पोजीशन वेक्टर ऑफ योर पार्टिकल with respect to the previous coordinate system. So your previous coordinate system, your origin was here, your potential was found, I was trying to find a potential at this point which was at a distance r. Now in the displaced coordinate system, my origin is now at this point. I don't want to mess it up, otherwise like ये ऐसा कुछ और होगा, मतलब ये तुम्हारा पूरा coordinate system displace हुआ है, तो I just don't want to mess the diagram, that's why. So ये ऐसा पूरा coordinate system ही खिसक गया, ठीक है? So your entire coordinate system has been displaced by r vector p. So now your new origin is at rp vector from the previous coordinate system. मतलब previous origin से rp vector पे. So your new origin position vector itself is rp vector with reference to this. Is that clear or not? So this distance would be r vector minus rp vector, isn't it?
हाँ भैया.
Okay, so थोड़ा अगर ध्यान से देखोगे तो जो higher order terms हैं, they contain the term rp. They contain the term of rp. Is that clear or not clear? ये चीज समझ में आई? ठीक है. सो अब देखो, तुम्हारा जो पुराना पोटेंशियल था वी आर वॉज गिवन बाय, आई थिंक इट वॉज, एक बार सिंपल लिखते हैं 1/4 पाई एप्सिलॉन नॉट, इतना इसको कॉम्प्लिकेट नहीं करते, समेशन क्यू आई और आई थिंक 1/r, देन प्लस आई थिंक आई शुड राइट समेशन क्यू आई ए आई डिवाइडेड बाय r स्क्वायर, एंड देन आई थिंक देयर वाज cos थीटा एंड सो ऑन एंड सो फोर्थ. मैं ज्यादा इसको कॉम्प्लिकेट नहीं करता हूँ, तो समझ में आना बंद हो जाएगा. Is that clear? Now instead of r, I'm replacing r vector minus rp vector का mod. So now after the transformation, I'm replacing r vector by r vector minus rp vector. अगर ऐसा करते हैं तो क्या होगा? 1/4 pi epsilon naught, and this is summation qi, and then there would be, instead of 1/r, I will get, because now r की पावर n था, तो n की जगह अगर 1 लिखता हूँ, यहाँ पे क्या है? r की पावर 1 ही तो है. So अगर यहाँ लिखता हूँ तो यहाँ पे आएगा r plus there is 1/r square, but this term would contain some function of theta. It would contain some c. It would also contain some rp, and so on and so forth. ये पहला टर्म देखो, 1/r की पावर 1 की जगह आ जाएगा 1/r plus 1/r square f of theta c rp, or so on and so forth. Is that clear? And the second term would again involve summation qi ai, and now instead of like this cos theta would remain, so I'll write cos theta here. So now instead of 1/r square, you will have what? 1/r square would be there, but again the higher order term c f of theta rp, and there would be r cube, so on and so forth. Is that clear or not clear? और higher order terms और चलती रहेंगे आगे के terms. Is that clear or not clear? ये चीज समझ में आ रही है, नहीं आ रही है?
Yes, sir.
Okay.
हाँ
Now
भैया.
you can see that the lowest non-zero, you can say, moment term in the expansion is independent of the change of origin, is independent of the change of the origin, because origin changed to RP vectors. Clearly your RP vector is associated with term 1 upon r square. So you can say that here 1 upon r square is there. So there is one term which contains a sort of dipole kind of variation. But again, understand this 1 upon r square is also there. And this term is dependent upon RP. So overall, you can say that your first term, that the lowest term, is independent of the choice of the coordinate. Is that clear or not clear? In this scenario, the lowest term is independent of the change of origin, or here I can say in this particular scenario, I can say that the monopole term is independent of the origin. Is that clear? Now, extra क्या पता लग रहा है इसके अलावा? If summation qi becomes 0, then this term would go to 0. If I'm writing, if summation qi becomes 0, then this term would go to 0, isn't it? This entire term would go to 0. सोच के जवाब देखो, this entire term would go to 0. If summation qi is 0, then this entire term would go to 0. Now, what is the leading term now? If you see, the leading term which is not dependent on RP is 1 upon r square cos theta summation qi. So now the leading term would be what? Now the leading term would be summation qi ai cos theta divided by r square, which is what? Which is the potential due to dipole. Is that clear or not? Further, yes, if the dipole moment becomes 0, then this term would go to 0. Then the quadrupole term would become, because the leading term would be summation qi ai ka square cos theta 1 upon r cube. Although these terms would be there, but I'm saying in that particular case, your quadrupole potential due to quadrupole would be independent of origin. Or in other words, I would say that summation qi ri, because understand all these terms are there, but understand that origin के reference में ये भी तो depend कर रहा है qi and ai क्या है, because this is what this is origin के reference में तो लिया जा रहा है qi और ai. So I would say that here indirectly I can also say that my dipole moment would be independent of origin. And similarly, if quadrupole moment has to be independent of origin, then summation qi must be 0. And if p vector is also 0, that is dipole moment vector is also 0, then it implies what? It implies your quadrupole moment or your potential due to quadrupole would be independent of origin. Is that clear or not clear?
Yes.
समझ में आई मेरी बात? चलो, let us do the case for this. Let us do the case for this in an easier fashion. In an easier fashion. Okay. Also understand this multipole expansion is not only restricted to electrical phenomena. Okay. So it can be extended to gravitational phenomena as well, or wherever you will find inverse square law forces. So your multipole expansion can also be extended to gravitational forces also, or in general for inverse square law forces. है ना? तो ऐसा कहीं कोई पूछे तो मैं इंटरव्यू में, तो this I think this is something that I can say. Although I yesterday also stated I have no such expertise on theory of gravitation or cosmology. I've never been into Steven Weinberg or any books of that sort, so I will not comment upon that. But overall, whatever little bit of information I can give, I am giving. Okay. Now, if you want to see it in an easier fashion, what I'll do is I'll take my origin coordinates. My original coordinates as simply x and y. And let us say my new origin is not displaced, and let's say this is x bar and this is, let's say, y bar. And originally my my volume element was d tau dash. So in any way, primed unprimed coordinates represents the charge inside the volume. So unprimed coordinate I'm taking for this. So this d tau dash was initially, let's say, at a distance let's say r vector dash from the old origin system, old coordinate system. So from the old coordinate system, this is my old coordinate system, this is my new coordinate system. Is that clear? And let's say my origin is shifted to a vector by displacement a vector. So my origin has been displaced by a vector. Is that clear? And let's say from in this coordinate system, my distance would then be given by let's say r dash or iska ek prime ek ऐसे. So because here there is a bar, so r vector dash bar and this would be, I'll write this r bar vector dash, I can write it as r vector dash minus a vector. Is that clear? यहाँ तक समझ में आया?
Yes, sir.
Okay. In old coordinate system, what can be my dipole moment? So my dipole moment can be written as p vector, which can be written as r vector dash dq dash, which is equivalent to r vector dash rho d tau dash. Is that clear? Now in new coordinate system, my p vector dash can be written as integration r bar dash vector or dq dash, which is equivalent to writing r vector dash minus a vector, and I think I will write simply rho d tau dash. Is that clear or not clear? So my p vector dash can be written as integration r vector dash dq minus a vector integration rho d tau dash. Is that clear? And what would be rho d tau dash? This is rho, matlab rho as a function of r dash, obviously. Okay. So rho as a function of r dash, this will be giving you what? This will be giving you the total charge q. Is that clear or not clear? So the dipole moment when the origin has been displaced is equivalent to p vector. This was the dipole moment in the previous coordinate system minus a vector times total charge q. Is that clear? So if your total charge q is given to be 0, then your p vector is equal to p vector dash. So I could say that if total charge q is 0, then the dipole moment is invariant of the change of origin. Is that clear or not clear? Is that clear or not clear?
Yes, sir.
Okay.
हाँ भैया.
And further, अगर थोड़ा सा ध्यान से देखोगे, अगर कभी भी देखोगे, if let's say your charges are distributed in this fashion, let's say you have minus q here, plus q here. So dipole moment like plus q here and plus q here and minus 2q here. So you can say that if there is a point of symmetry, so if the charge is symmetrically placed with respect to origin, symmetrically placed with respect to origin. So here you can see that total charge q is placed at a distance, let's say a from origin, and total charge q is placed, another charge q is placed at a distance a from the origin. So both of them are placed equally, and minus 2q is itself placed here. So you can say that your plus q charges are equally placed from the origin. So dipole moment will be 0, and indeed they are, because you can take minus 2k as minus q, and you can know that this has been done previously. This is linear quadrupole arrangement. So net dipole moment will become 0. So always remember, if the charge is symmetrically placed or origin is a point of symmetry, by which I mean that your charges should be symmetrically placed with respect to origin. Okay? Then the net dipole moment is always 0. And if net dipole moment is always 0, then indeed quadrupole moment would be the leading term. Is that clear or not clear?
Yes, sir.
Okay. So I hope to meet you in the next session, probably in 5 minutes or so. So let us take next session so that we'll finish it off. I know this is long class, but I can't help it. Okay. Will that be fine, or should I take it tomorrow?
Fine, sir.
Okay. Chalo.